Good morning, students. Today we are in section 5.2 and we are doing logarithms and logarithmic functions. I'll admit can be a bit confusing, but if you write down the first two pieces, those will help you with most all of your homework. So, um, what we're doing is we are going to be changing exponential functions into, excuse me, logarithms and back. Okay, so that's what we're doing today, is we're changing back and forth. Now, what in the world are they? Well, let's look at a regular exponential function. A regular exponential function has a base, and then you have your exponent, and that equals your answer. Okay, so you have your base, your exponent, and your answer. Example, let's do let's do 3 is our base to the fourth power. And that would be 3 times 3 is 9. 9 times 3 is 27. That would be 81. So our base, our exponent, and our answer. Now, what we're going to be switching it into is these logarithmic functions. And what that looks like is it's going to be log base answer equals exponent. Exponent. So, um, so an example of this would be log. Oops, I just broke my lid. Log 3 81 equals 4. So I have my base, my answer, and my exponent. Okay. So let's put these in little abbreviated forms. We get the base times the exponent equals the answer. And for the logarithmic function, we get log base answer equals exponents. I want to change this to a lowercase e because that's our exponent. Log base times the answer equals our exponent. So this is what you're going to use for this, much of this lesson is this right here. And you're going to be essentially just switching them back and forth between these two. Okay, let's look at what I mean. So example number 1. Let's do 2 to the third. What is 2 to the third? Well, that's 8. And if I ask you, please change that to a logarithmic function, we are going to go log, our base is 2, our answer is 8, and our exponent is 3. Our base is 2, our answer is 8, and our exponent is 3. So if you can follow this, that's all you have to do. All right, number 2, let's try it again. Oh, here's an interesting thing. So let's say 10 to the x equals 100. So it would be log 10, 100 equals x, right? So there it is. A side note, in the calculator, if you give no base number, no log, if you just write it like this, the calculator knows this as base 10. So in the calculator, log 100 equals x, that's log base 10. So this and this say the exact same thing. This and this say the exact same thing, because if the base is absent, then it is by default a base 10. So how do we solve this? Well, if we plug it into a calculator and we go excuse me, we go log. Let's see, we're doing this one. So we're doing base 10, so log 100 equals 2. Log 100 equals 2. So x equals 2. Now, how can we check this? Well, let's go up here. 10, so our x is 2, so 10 squared. Well, 10 times 10 equals 100, so it checks out. So in the calculator, this is a base 10. It's a base 10. All right, let's look at a third example. Excuse me. E, that exponential growth or decay, to the x value equals 2. So that's a number we learned about last lesson, 5.1. So let's change this into a logarithmic function. So if we look up here, we have log base. So our base is e. So log e, and then our answer is 2, and our exponent is x. Well, here's a neat thing. This log e, if I go log e in my calculator, log base e equals, it's just ln, or natural log. So log e is just natural log. So where is it? ln, why am I not finding L? Oh, there, it's not a, it's right here. So ln, log e is just natural log. So ln, for my problem here, ln, so log e is just ln, so ln 2 gives me 0.693. So x equals 0.693. I'm going to get one more highlight in here. Log e equals natural log. Log e equals natural log. Okay. And then this is definitely a part to highlight. Okay. Let's move on. Example number 4. Let's go the other way. Log 4 of 16 equals x. Well, let's move this around to be this. So we have our base 4. We have our exponent 4x equals 16. Well, how many times do I multiply 4 by itself to get 16? Well, I multiply by itself once, so 4 squared. So x equals 2. Let's go with another base 10. If we have log of 1,000. Well, if I don't write my base here, I know that it's log log 10. I know that's base 10. So I know my base value is 10. Equals x. So what's my exponent? So my base value is 10. My exponent is x. It equals 1,000. Well, how many times I multiply 10 by itself to get there? 3. So x equals 3. 10 to the third equals 1,000. Let's do another one of these natural logs. So let's go. The natural log of x equals 4. So I know the base of the natural log, the base is e. So e to the fourth equals x. So e to the fourth, and I get 54.6. X equals 54.6. All right, you still with me? Okay, so a couple more examples. So example number 7, I get log 3 81 equals x. So what's my x value? Well, my base is 3. My exponent, I don't know, equals 81. Well, 3 times what, or 3 to what power equals 81? 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So that's 4. So x equals 4. Couple more. Log 5 to the 1. So what would my exponent be? So I have log 5 to the 1 equals what? So I have my base of 5. My exponent equals 1. Or how do I get, what exponent of 5 gets me to 1? That'd be 0. So x equals 0. All right, last example, log of 431. So this would be a log of base 10, right? Equals x. So I have my base is 10. And we get 431. So, you know what? The easiest way, actually, I'm just going to plug in log 431. And I get 2.63. X equals 2.63. So this one actually, in order to solve one like this, I would go backwards up to here and plug it in the calculator as a log problem. Log 431 equals 2.63. So there we have it. All right, your homework is page 146 to 147, numbers 1 through 14. All right, have fun. Let me know if you have any questions. And Yahoo!